Now we'll start with the third lecture. In this lecture, we'll see what is correlation and regression. Up till now, we have taken the data in which we have a single variable x. But if we have two variables, if we have a data in which two variables are involved, x and y, then and if you want to check whether they are related to each other or not, and if you want to find the relation between them, that we can get by using this correlation and regression. So firstly, we'll see what is a correlation, and then we'll take the problems based on this concepts. Okay, so firstly, we'll see what is a correlation. So if you're having a tabular data of x and y, if you want to check whether they are related or not, is what is the relation? If x is increasing and if the corresponding values of y is also increasing, or if x is increasing and if values of y are decreasing, then we say that they are correlated. Means increase or decrease in one variable, if it affects the increase or decrease in the other variable, then that two variables are said to be correlated. If both increase or decrease simultaneously, then that correlation is said to be positive. If increase in one will give us the decrease in the other variable, or decrease in one will give us the increase in the other variable, then they are said to be negatively correlated, or the correlation between them is negative or opposite type of correlation. And if increase and decrease in increase or decrease in one variable does not affect the increase or decrease in the other variable, then they are said to be independent. Okay, because many times while doing the practical or by doing some experiment, there are variables, means there are many outcomes we are getting from that experiment. And if you want to check whether one depends on other or not, whether one related with the other or not, okay, for that this correlation is used. And different types of correlations are there: positive, negative, or no relation. Now, how to make use of the tabular values, or what are the formulas for finding this correlation? There is one formula by which we can get this correlation, and that formula is called as a Carbeason's coefficient of correlation. So you'll see that formula. It is denoted by Rxy or R suffix xy, and the formula is summation xi yi divided by n minus x bar into y bar divided by square root of summation xi square divided by n minus x bar square into summation yi square divided by n minus y bar square. Okay, so this is a standard formula for checking the relation between the two variables or finding the correlation. If this Rxy is positive, then both x and y increase or decrease simultaneously. If Rxy is negative, then when one increases, the other will decrease, or when one decreases, other will increase. That is opposite type of correlation. And if Rxy is equal to 0, then the two variables x and y are independent. Okay, so carefully remember this basic formula. We know what is x bar. X bar is nothing but summation of all x divided by n. Y bar is summation of all y, that is summation yi divided by n. If you look at this term, the square root of this term, this is nothing but a sigma, standard deviation, formula of standard deviation. So already this formula we have learned: standard deviation, square root of all this term is a sigma x. This square root of x y square by n minus y bar square is sigma y. Okay, so Rxy is nothing but sigma xy divided by n minus x bar y bar. This we can write it as sigma x into sigma y, or you can remember the formula in terms of this square of this term, summation x square by n minus x bar square summation y square by n minus y bar square. Okay. Now there are some restrictions for this formula. There are some limitations for this formula. Okay, this Rxy is always between 1 and minus 1. We never get the value of R which is greater than 1 and which is less than -1. It is always between -1 and 1. Okay, remember this bound. Okay, because this may be asked for MCQ, multiple choice question. What are the limits for Rxy? Okay, then one must know these values. What are the limitations? It is always between -1 and 1. Okay, we cannot get the value greater than 1 or less than -1. Okay, and carefully remember this standard formula. Okay, for when your tabular values are given, we have to make the columns of x into y, x square, y square, and then making use of these summations, we can easily find R. Okay, and depending on this limitation, we can check whether our answer is correct or not. It must be between -1 and 1. Okay. What are the type of data table we have to make? We have to make these extra columns: x square, y square, x into y. Okay, we are given the values of x and y. Then we have to make these 3 extra columns, and we have to find the summation of all these 5 columns, because this summation x we require for finding x bar, this summation y we require for finding y bar, and these summations we use in this formula. So if we just remember this thing, okay, this format of the table and this formula, we can easily solve problems on this correlation. Okay, we'll take a problem and then we'll see how to make use of the table and this formula to get the answer. 10 students got the following percentage of marks in semester 1 and semester 2. Calculate the coefficient of correlation. Okay, semester 1 marks are 78, 36, 98, 25, 75, 82, 90, 62, 65, and 39. And in semester 2, marks are 84, 51, 91, 60, 68, 62, 86, 58, 53, and 47. Okay, so if we know the data, then if you want to check whether there is a relation between these two variables, semester 1 marks and semester 2 marks or not, okay, then directly by looking at the data, we cannot make any prediction. Okay, so for that, we have to use this formula of correlation. Okay, Carbeason's coefficient of correlation. If that formula, if we get the value of R to be positive, then if there is an increase in one variable, the corresponding there will be increase in other variable. And if it is negative, then one increases, other will decrease. And if it is 0, then no relation. So we will check by finding the value. And for that, we need a table. So you take any one as x, take the other variable as y, and then make a table taking semester 1 marks as x, semester 2 marks as y, and then making the columns x square, y square, x into y. And already we know how to take this, do the calculation. Just take the square of each x, square of each y, take the multiple corresponding x and y terms, 78 into 84, 36 into 51, like that, complete this table and summation of each term. And in the formula, n is there. N means the total number of terms, total number of observation. And as these are the marks of 10 students, n is 10. Okay, n is the number of terms. Small n means number of observation. Capital N means summation of frequency. Summation f is capital N. Small n is number of observations. Now just complete the table. Taking the summation of x square, summation of y square, then taking the product x into y, and then take the sum of each column, all 5 columns. Okay, so if we take the summation, the summations comes out to be summation x is 650, summation y is 660, x square is 47648, y square is 45784, xy is 45604. Okay, now make use of this summation and put it into standard formula. So here n is 10, finding x bar and y bar. X bar will be summation x divided by n. Y bar is summation y divided by n. Already we know what are the summations from the table. So using that values, it will be 650 by 10. That will be 65. Y bar will be 660 by 10. That will be 66. Okay. And now use the formula correlation. It is denoted by RXY or only R. You can use any notation. Single R also represent a coefficient of correlation, or you can use R suffix XY. No problem. Now substitute the values. This summation, take it from the table. N is 10, X bar is 65, Y bar is 66. This summation X square, take it from the table. N is 10, summation X bar, sorry, it is X bar square, that is 65. Summation yi square, take it from the table. N is 10 and y bar is 66. Take its square. Simple substitution is there. Then simplify it. Take the product. Don't forget to take the square root of it. And don't forget to check whether we are getting the answer between 1 and -1. If we are not getting answer in 1 and -1, then somewhere we have made a mistake. Okay, so suppose after getting the answer, don't forget to check. And after simplify, we get the answer 0.787. It is less than 1 and greater than -1. So we got this coefficient of correlation. Now, as this R is positive, and what is the meaning of positive R? There is a relation, positive type of relation. Both X and Y increase or decrease simultaneously. Means if you are having good marks, means from this data we can say that if you are having good marks in semester 1, you will get good marks in semester 2. Okay, so that is a prediction we can make from this data. Okay, answering the second problem, calculate the coefficient of correlation for the following data. Values of X are 35, 34, 40, 43, 56, 20, 38. Y is 32, 30, 31, 32, 53, 20, and 33. Now again, we want the coefficient of correlation. That is, we want the value of RXY. And for getting that, we need 3 extra columns. So what are that columns? We have to make X square, Y square, and X into Y. And then summation of that each column. So complete this table. Taking X square, Y square, XY. Take the square of each X. Take the square of each Y. And take the product of corresponding X and Y. Okay, and complete the table. So I will just take the values. 35 square, 1125. 34 square, 1156. Like that, taking the square of each X. Same way, take the square of each Y. And take the product of X and Y. 35 into 32, it will be 1120. 34 into 30, it will be 1020. Like that, taking the product of each pair X and Y. Now take sum of each column. Taking the summation of each column gives us summation X is equal to find the sum of each column. Then N will be the total number of observations. Now here, how many terms are there? There are total 7 observations. So N will be 7. Okay. Summation X will be 266. Summation Y will be 231. Summation X square 10810. Summation Y square 8207. Summation XY is 9378. Okay. Use these summations and use the standard formulas. N is 7. X bar will be summation X divided by N. Summation Y bar will be summation Y divided by N. Taking the values from the table, it will be 266 by 7, that is 38. 231 by 7, that will be 33. And value of R is summation Xi Y by N minus X bar Y bar divided by square root of summation Xi square by N minus x bar square into summation yi square by n minus y bar square. I put all these summations from the table in this formula. So rxy will be summation xi y from the table is 9378 by 7 minus x bar is 38, y bar is 33 divided by square root of all this term. Okay, take the product, take the square root and do the calculation. And then it will give us the answer 0.937. And you can see that it is less than 1. So our answer is correct. Okay, we must get the answer between 1 and minus 1. Now, how the problems will be asked on this correlation? The formula may be asked, what is the formula of Rx, Y? This formula may be asked for MCQ, or we are given the values of x bar, y bar, summation xi square, yi square. All these summations are given. And then what is the value of R? That may be asked in exam. It will not ask to prepare a table, because preparing the table is not, means for multiple choice we cannot have the preparation of the table. So these summations may be given, all these summations, and finding the R, that type of problems may be there for multiple choice question. Limitations for R, what are the extreme values, -1 to 1, in between that limitations may also be asked for the multiple choice question. Now, by using correlation, we checked whether there is a relation between the two variables or not. But what is that relation? That we don't know. So how to check the means how to get the relations between that two variables? If they are related, then how to get the relation between them? So for getting the relation between them, we are having the next term, that is a regression. So for finding the relationship between x and y, we use the next concept, that is regression. Notice this means how this method works. Many times what happens, we are having a data of x and y, and if any of the data, any of the value of either x or y is missing, and if you want to make the prediction, or if you want to find that missing value, okay, then that we can get by using this regression analysis. And for finding that value, we must have the what is the relation, what is actual relationship between x and y. Okay, so for finding that relationship, we use regression. How this regression works? If we plot all these points x and y, we just draw a graph and put the corresponding tabular values of x and y as, and plot that as a point. Okay, take the x coordinate and y coordinate as these values of x and y, and then plot that point. Then we have the curve passing through maximum points, that we call as a regression curve. Okay, the curve which passes through the maximum number of points, it's called as regression. And if regression curve, and if that curve is a line, then it is called as a line of regression. And we are going to see how to find that line of regression. Okay, what is the formula for it, and what is the use, means after getting that regression line, how to solve the problem. So what are the line of regression? There are two types of lines of regression. The one is y on x, and it is given by the formula for that is y minus y bar is equal to the formula is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. and regression line of x on y is x minus x bar is equal to r into sigma x by sigma y into y minus y bar. Okay, we use regression line of y on x by using this formula, and whenever we want to find a value of y when the value of x is given, we use this formula, because just taking y bar to other side we can easily find the value of y. And if it is if value of x is missing for the corresponding, then and value of y is known to us, then put that value of y over here, take x bar to other side, we can easily get the regression. We can easily get the value of unknown value of x. Okay, so if you want to find the value of y, use the regression line of y on x, and if you want to find the value of x when y is known, then use the regression line of x on y. Okay. Now, why these different lines are there? Actually, there are plenty of lines which passes through all that points. What happened by using regression line of y on x, we try to reduce the distance between all x and x bar. Okay, we try to reduce the distance between x and x bars to get the more accurate value for y. And in regression line of x on y, we try to reduce the distance between y and y bar, all y terms and y bar. Okay, so accordingly we get the different lines. And the property, there is one important property of these two regression lines. Okay, these two regression line passes through x bar and y bar. Okay, these two regression lines satisfies the point x bar y bar. Why it is so? Because if we replace x by x bar and y by y bar in both these equations, then what happened? Y bar minus y bar is 0. X bar minus x bar, it comes out to be 0. So we get 0 equal to 0. So x bar and y bar satisfies both these regression lines. That is very, very important property of these regression lines. Okay. We know what is the formula for R. Correlation formula already we saw. Sigma x standard deviation, that formula also we are taken. So we can make use of that formulas. X bar, y bar also we know. Making use of that formulas, we can get these regression lines. Now, there are some names for this R into sigma x y by sigma y. Okay, these terms are called as a regression coefficient. R sigma y by sigma x, it is denoted by byx, and R into sigma x by sigma y, that is denoted by bxy. Okay, these are called regression coefficient.
Sir, now, sorry to
what happens if you take the product of byx and bxy? Okay, if we take the product of hello.
Sir, your voice is lagging. Sorry to interrupt.
Okay. Okay, I will talk slowly then. So we are having this regression coefficients. This regression coefficient is denoted by byx and R into sigma x by sigma y, that is denoted by bxy. Now, if we take a product of these two terms, product of bxy and byx, then what happened? Sigma y get cancelled, sigma x get cancelled, and we get R into R, that is R square. Okay, so bxy into byx is equal to R square. And if we take a square root on both sides, R will be plus or minus square root of bxy into byx. Okay, and if R is plus or minus 1, then it is called as a perfect correlation. Okay, and in that case, we'll get the same lines. Okay, because all the points, there is a single line which passes all the points. So in that case, R become plus or minus 1, and we get a single line. And these two different lines we get because there are many lines which passes through all that points. This is one of the line in which distance between x and x bar is very less, and this is the line in which distance between y and y bar is very less, then we get one and the same. Okay. Now, what type of problems will be there on this regression line? We are given a tabular values of x and y, and it is asked to find what are the regression lines. Then we have to use the formula of R, sigma x, sigma y, x bar, y bar. Substituting in this, we can get the answer. And the other type of problem is we are given the regression lines, and it is asked to find what is R. So in that case, we have to get the regression coefficients first, and by taking plus or minus square root of this term, we get R. Now, how to decide the sign of R? Okay, we have to decide the sign of R depending on the sign of bxy and byx. If both bxy and byx are positive, take R positive. If both bxy and byx are negative, take R negative. Okay, we cannot have one negative, one positive, because the product square root of negative will become imaginary. So both must be either positive or both must be either negative. Both positive, take R positive. Both negative, take R negative. Okay, we'll take a problem, then you understand how to make use of all the formulas to get the regression lines. Okay. So consider the first problem. Find the regression line of y on x for the following data and estimate the value of y when x is equal to 10. The values of x and y are 1, 3, 4, 6, 8, 9, 11, 14, and values of y are 1, 2, 4, 4, 5, 7, 8, and 9. Okay. So we want to find what is the regression line of y on x. And we are given the value of x. Okay, we know some value of x, and for that, what is the corresponding value of y? That we have to get it by using this regression line. Okay. So in correlation, we saw how to check the relation between the two, and in regression, we can find the actual relationship between them, linear relationship between them. Now we know what are the columns we need for calculating R. We need to find what is x square, what is y square, and what is x and y. So same type of table we have to make it for this regression also. So make 3 extra columns, x square, y square, x into y. Okay. Now do this calculation. Simple calculations are there. We have to take this square each term, 1 square, 3 square, 4 square, like that. Take the square of each term. Summation of, then take the summation of each column. And then take the product of x and y. Okay. So completing the table. Finding the sum of each column, summation x will be 56, summation y is 40, summation x square comes up to be 524, summation y square is 256, and summation xy, it comes up to be 364. Now use all these summations in the standard formulas. And for that we need what is x bar, y bar, what is n. N means total number of terms. Here there are total 8 observations, so taking n as 8, x bar will be summation x, which we get it from the table, that is 56 by 8. Summation y is 40 divided by 8, that will be 5. Then we have to find what is sigma x, sigma y, standard deviation. And standard deviation formula is summation x square by n minus x bar square. Sigma y is summation y square by n minus y bar square. So use these summations from the table. X bar is 7, y bar is 5. So using that values directly. So sigma x comes out to be 4.0. 0.062, sigma y is 2.64. Now use the formula for r. R is square root summation of xy divided by n minus x bar into y bar divided by square root of xi square by n minus x bar square summation yi square by n minus y bar square. If you want, you can put the summations from the table or this square root of all this term. This is nothing but sigma x. So you can use this value of sigma directly. X bar y bar, take it as 7 and 5. Xy summation, take it from the table. Okay, so it will be 364 divided by 8 minus x bar is 7, y bar is 5. This first term under square root is sigma x, that will be 4.062, that already we have calculated. The second term under square root is sigma y, that is 2.64. Do the calculation, it will give us r as 0.977. Okay, it is less than 1, so it is correct. Okay, and there is a positive type of correlation. Now, use the formula of regression line of y on x. And the formula is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Now put the value of r, put the value of sigma x, put the value of sigma y, x bar and y bar. So we get y minus y is equal to 0.977 of sigma y is 2.64 divided by sigma x is 4.062 into x. Okay, so just simplify it, take the product of these terms. It will be 0.6347 into x minus 7. So this is the regression line of y on x. Now there is one more part. We are given the value of x and it is asked to find the corresponding value of y. So just put that given value of x into that right hand side of the equation. So just put x equal to 10. So putting x equal to 10 in this side, 6.6349 into 10 minus 7, and take this 5 to other side. Now take this minus 5 to other side and then simplify it. So it gives us y is equal to 6.9049. Okay, so this is also very easy and very important one. Carefully remember the format of the table. We need to make 3 extra columns, x square, y square, x into y. Then use this formulas of r, sigma x, sigma y, x bar and y bar, and this formula for regression line of y on x, and simplifying it, we can get the answer. Okay. Consider the next problem. The equation of regression lines are 2x is equal to 8 minus 3y and 2y is equal to 5 minus x. Find the mean of x and y and obtain the value of correlation coefficient. Okay, so this is the second type of problem we'll have on the this regression lines. We are given both the regression lines and it is asked to find value of r and x bar y bar. Already I told you there is one important property of regression lines. Both regression lines passes through x bar and y bar. That is, both satisfies x bar and y bar satisfies both equations. So what to do? Just replace x by x bar equation. That gives us the two equation in terms of x bar and y bar. And solve that two equations, we get x bar and y bar. That will be the mean of x and y. Okay, so we are using the property that x bar and y bar satisfies the equations of regression lines. We get 2x bar equal to 8 minus 3y bar, 2y bar is equal to 5 minus x bar. Now we know how to solve these two equations simultaneously. You can solve these equations on calculator also, or you can do the direct simplification. You can take all xy terms on one side and then simplify the terms. Okay, and solving these two equations simultaneously, two equations, two unknown. Okay, on calc you can get it easily. X bar comes out to be 1 and y bar comes out to be 2. Okay, or otherwise you make coefficient of x same, multiply this equation by 2, add it to first equation, x get cancelled. Now it can get a value of y bar. And the other ways you make the coefficient of y bar same, take the subtraction or addition, cancel y bar terms and get x bar. That gives us x bar and y bar. Okay, so this is the first part, mean of x and y. The second is finding the coefficient of correlation. And already we saw the formula for R. There is one formula in terms of coefficient, that is R will be plus or minus square root of bxy into pyx. Now what is a bxy? It will be the coefficient of x when the coefficient of y is 1. Okay, and the byx will be coefficient of y when x when the coefficient of y is 1. Okay, so let 2x is equal to 8 minus py be the regression line of x on y. 2y equal to 5 minus x be the regression line of y on x. Now here it is not mentioned which is x on y and which is y on x. So you take any one as x on y and other as y on x. Okay, you can make any choice. Only thing we have to check is R must be between minus 1 and 1. If R is not in between minus 1 and 1, then the choice of whatever choice we have made, x on y or y on x, that must be wrong if R is not between the interval. Okay, so randomly do the choice. You take any one equation as x on y, another equation as y on x. And what is the equation of x on y? X minus x bar is equal to bxy into y minus y bar. In that case, the coefficient of x must be 1. X minus x bar equal to something. So coefficient of x must be 1. So remove this 2. Regression line of y on x, we must have y minus y bar equal to something into x minus x bar. So in that case, the coefficient of y must be 1. So remove these coefficients. Remove this 2 and 2. Okay. So what happened? The equation becomes x is equal to, we are dividing by 2, whole equation by 2. X is equal to 8 by 2 minus 3 by 2y, and here also dividing by 2, y will be 5 by 2 minus x by 2 into x. When the coefficient of x is 1, the coefficient of y will give us the regression coefficient. This coefficient of y will be bxy, and when the coefficient of y is 1, the coefficient of x will be byx. So here this coefficient is bxy, that will be coefficient of y minus 2, and coefficients will be bix minus half. And now take the product of these two terms. R square will be minus 3 by 2 into minus half, that will be 3 by 4. And now take square root on both sides. So R will be plus or minus square root of 3 by 4. That comes to be 0.866. And already I told you that if both bxy and byx are negative, take this R to be negative. And if both are positive, take R to be positive. Here these are negative, both the terms are negative, so we are taking negative value. Otherwise we have to take the positive root. Okay, so this is R since both are negative. So how to solve this problem when you have two regression lines are given? Okay, take one equation as x on y, make the coefficient of x1, whatever coefficient of y, take it as dxy. Take the another equation, coefficient of y1, and whatever coefficient of x, take that as product of these two and square root of that. If both these are negative, take R negative, and if both these are positive, take R positive. So very easy, very important. If this R is not between minus 1 and 1, then reverse the choice, because it may happen that because here it is not mentioned which is x on y and which is y on x. So that choice depends on the answer of R. If you get R between 1 and minus 1, then our choice is correct. If R is not
Sir, you are not audible, sir.
हॅलो सर आवाजच येत नाही.